Okay, so we're going to start with distribution, but it's not distribution of base numbers. We need to distribute exponents. Okay, now what I want you guys to remember here is that when you distribute your exponents, there's one thing you need to be careful of, and that's bases that don't have exponents. Not necessarily don't have exponents, but it's to the power of 1. Okay, so little note over here is that we mustn't forget our linker ones. Okay, so what I normally do is I go add it in before I go and distribute my ones. Okay, so I know it's 2 to the power of 1, 8 to the power of 1, and 2 to the power of 1 here as well. Okay, at the bottom. Can you all see?
Yes, ma'am.
Right, I'm now going to start with distribution. Okay, so we are going to distribute exponents with exponents. Do you understand me? Okay, so we're going to multiply, because remember brackets represent multiplication. 2, 2, and 2. So we're going to have 2 to the power of 2, a to the power of 4, b to the power of 6. No. Remember, distribution is the process of getting rid of brackets. You don't need to put that bracket back. Okay, multiplied by, we're then going to do the same over here. So it's going to be 3 times 1, 3 times 4. So it's going to be a to the power of 3, b to the power of 12. Okay, and then same for at the bottom. I'm going to go and distribute the 4 to all the exponents on the inside. So it's going to be 2 to the power of 2 to the power of 4, because 1 times 4 is 4. A to the power of 12, b to the power of 8. Okay, so what I'm going to do next is I'm going to first simplify the top. Okay, and how do we simplify the top? Not like terms, we are not multiplying. We're going to use our exponential law number 1. When we multiply with the same base, we add our exponents. Okay, so I'm just going to write our law 1. Okay, what is 2? Okay, so 2 to the power of 2 is what? Okay, it's 4, correct? 2 to the power of 2 is 4. Okay, 4 times 1 is 4. 2 to the power of 2 is 4. Okay, so 4. So we simplify on the top now. 4 times 1, because there's an integer 1 there as well, hey? 4 times 1 is 4. Okay, a to the power of 4 times a to the power of 3 is a to the power of 7. B to the power of 6 divided by b to the power of, times b to the power of 12 is b to the power of 18. Okay, you guys okay? Yeah. Okay, all divided by, in your calculator, 2 to the power of 4 is 16. So this is 16, a to the power of 12, b to the power of 8. Okay, are we okay? Right, yes. 2 to the power of 4 simplifies to 16, and then you just write the rest down. Okay, which law are we going to use here? Law 2, which is when our bases are the same and we are dividing, we subtract. Now, but remember, your name in grade 10 is alternative. The way I'm going to do it might not necessarily be the way you're going to do it. As long as we get to the same answer and as long as your mathematics is correct. Okay, so we're going to use law 2 here. which is our division law. Okay, so I'm going to go ahead and I'm going to go say 16 divided by 4. You put it into your calculator, you get 1 over 4. Okay, now a lot of you might just go say, okay, 8 to the power of 7 divided by 8 to the power of 12 is going to give me 8 to the power of negative 5. Okay, or just to make it easier, you take one of the smallest exponents, you take it down to the bottom, okay, and this is going to become a minus 7, right? Okay, and you know then at the bottom we're going to have 8 to the power of 5. No, the 7 goes down to the 12.
And then 12 minus 7.
Yes. Okay? Now, are we going to take, have a look, are we left? Are we going to take the 18 down to the 8 or the 8 up to the 18? Okay, and it's positive. When you take it up to the top, it becomes a negative. So how many B's do we have left? 10. And it is on top. Okay, so it's going to be B to the power of 10. And that's your final answer. We can see we've got a slight problem because our rule for multiplication says only when our bases are the same can we do something with our exponents. Are you with me? Okay, so looking at the numerator, we can see our bases are not the same. We've got two bases that are the same, the 2 and the 2. So we can maybe do something there, but what's going to happen to the 4? You can't go and multiply the 2, the 4, and the 2, because that's not a rule of exponents. Okay? And the 16, what's going to happen to the 16? So do you see over here, our bases are like upside down? Okay. Right, so if our bases are not the same, okay, and the rule of exponent says the bases need to be the same, what are you going to do? Okay, we're going to make our bases the same. And what's the only way we can do that? Okay, we're going to make the bases the same. I'm just going to zoom out a little bit. Okay, we're going to make the bases the same. Hello, when I say it now, you're going to want to fall off your chair because it's so easy. What are we going to do? Okay, so the problem is, which problems are there here? Which numbers are a problem? 4 and? Okay, there's your hint. So what are we going to do with that 4 and 16? No! Yeah? How? No! No. Give me a calculator, Mama, doesn't it? Okay? Okay, so the 4 is the problem, right?
Yes, ma'am.
4 equals shift fact. So 4 we can write as 2 to the power of 2. Okay, so 2 to the power of 2 minus 1 times 4 we can write as 2 to the power of 2. But you guys understand why I put it in brackets? Is because this 2 to the power of 2 is your 4. That 4 is still to the power of n plus 1. You understand? Okay, so how do we make the bases the same? We're going to
Shift fact.
okay, prime factorize, shift fact.
Oh, it's prime factorized.
Yeah. Okay, we're going to prime factorize by doing shift fact. Okay. And then we've just got the times 2 here. Okay, so with multiplication, our first step is to make our bases the same. Are you guys with me? Okay, so the other one we need to do is 16. So we're going to go say 16 equals shift fact, and that's 2 to the power of 4, but we are going to leave in brackets because that 16 is still to the power of n. Understand? Okay, so this is going to be 2 to the power of 4 Keep it in your bracket because that's still to the power of n. Right, we have now made all our bases the same. Okay, you with me? Okay, so our second step, what do you think our second step is going to be, grade 10s? Obviously.
Distribute.
Thank you. Okay, we're going to distribute our exponents. Okay, we are going to distribute our exponents. Okay. And distributing our exponents is over here. So a lot of you are going to forget to multiply the 2 with the 1 as well. I promise you, you're going to forget. Please don't.
So then, how do you write it into n?
Okay, so it's 2 times n, 2 times 1, and 4 times n. It's the same as normal distribution. Everything on the outside must get multiplied with everything on the inside.
Oh, because it's 2 times.
Yes.
You don't have to multiply 2 times n.
This one.
To the power of 1.
Yeah.
Like we don't have to multiply 2 and then 8 plus 1. Because it already has an exponent.
Yes, it's your exponents, yes. Okay, so it's 2 to the power of 2n minus 1 times 2 to the power of 2n plus 2. I'm going to circle this in red. Okay? Times 2. Okay, divided by 2 to the power of 4n.
So when most people distribute the brackets below.
Yes, distribution is the process of getting rid of your brackets. Okay, your third step, I always like to simplify numerators and denominators before I start switching up between top and bottom. But then at the end of the day, it's completely up to you. I just find it easier when it's fully simplified at the top and the bottom than to start. Okay, so I'm going to simplify my numerator. Okay, and what law am I going to use to simplify my numerator, grade 10s? I'm going to use law 1, right? Okay, and law 1 states whenever our bases are the same and we are multiplying, we add our exponents. Okay, so I keep my base, 2 to the power of 2n minus 1 plus 2n plus 2. There's no need to put it in a bracket because remember, a plus sign causes no problems for us. It's only the negative. Are you with me? Okay? Right, is that all?
No.
Okay, why is it not all?
Because 2 has an exponent of 1.
Okay, 2 has an exponent of
1.
1. So we're going to add 1 over here. And we are still dividing by 2 to the power of 4n. There's nothing to simplify there. Right, let's look for like terms in our exponents. Grade 10, we've got 2n plus 2n, which is? Okay, so we're going to have 2 to the power of 4n. Minus 1 plus 2 is 1. 1 plus 1 is 2. So 2 to the power of 4n plus 2. All divided by 2 to the power of 4n.
4 ends above. Are we adding?
Okay, are you guys okay? Right. Our fourth step, grade 10s, is to take everything to the top. Take everything to the top. Or use law 2, which is when your bases are the same and you're dividing, you subtract. Okay, but I like to just take everything to the top. Okay. And when you take everything to the top, remember we're switching its position in the fraction, which means the exponent's value changes. Okay, so when we take this 4n, when we take it up, it becomes a
Negative.
minus 4n. Are you with me? Then this 2 to the power of 4n is gone because we've taken it up. Understand? Okay, in my numerator, 4n minus 4n cancel each other out. I'm left with 2 to the power of 2. Are you with me? Your answer is 4. Okay, what do we do? Okay, problems. Where's our problems? Okay, so the 6, the 27 and the 18. Okay, so first step is, I'm not going to rewrite the steps because we've already written it before. Your first step is to try factorize. Okay, so we're going to have 2 to the power of 2n minus 1 times 6 equals shift fact. It's going to be 2 times 3, but we keep it in brackets. Okay, so 2 times 3 to the power of negative n plus 1. Okay, and the 27 is also a problem, so we're going to have 27 equals shift fact. We're going to have 3 to the power of 3. In brackets, bless you. Okay, so 3 to the power of 3, and that's all to the power of n. Okay, but now you guys are probably thinking, oh my soul, there's still something wrong because not all my bases are a 2 and not all my bases are a 3. But that's okay, as long as we only have 2s and 3s, because then we do have the same base. We just have 2 different same bases, if that makes sense. Okay, 18 equals shift fact, and we get 2 times 3 squared, again in a bracket. Okay, 2 times 3 squared, and that's to the power of n. Okay, what was our second step? Okay, we are going to distribute to get rid of our brackets. Okay, so the first one stays just like it is. Okay, tricky part. What are we going to do here, great sense? To when? To both? Okay, because 2 has its own exponent of 1. And 3 has its own exponent of 1. Okay, are you with me? Yeah?
I think it's going to be like easier for us to write a one way.
No, yes, I normally do. Okay, so we're going to say 2 to the power of negative n plus 1. We've just taken this in here. Okay, you with me? Times 3 to the power of negative n plus 1. I've just taken it in here. Yeah?
Do you say 2 times negative n plus 1 and you say 2 times negative n and then 2 times
2.
2?
Okay, times 3 times n is 3n. Are we okay? Right, over here, 2 has its own exponent of 1. I forgot the 3. I didn't, it's there. It's there. Thank you. Okay, so we're going to have at the bottom 2 to the power of n. Okay, so I just print it like that. Times 3 to the power of 2. Good job. Good job. Okay. My next step, I said I'm going to simplify numerators and denominators as far as possible, and then I'll start jumping between top and bottom. Okay, so my law says when my bases are the same and we are multiplying, we add exponents. It's okay for us to have 2s and 3s. We're just going to group them together, that's all. Okay, so we're going to group that one and that one. And we're going to simplify that. So it's going to be 2 to the power of 2n minus 1 minus n plus 1. Okay? And then I'm going to group my 3's. Okay, so it's times 3 to the power of negative n plus 1 plus 3n. Okay, we good? All divided by nothing to simplify at the bottom because our bases are not the same. Okay, let's look for like terms in our exponents now. So what is 2n minus n? 1n. Grade 10, are you with me? Okay, so we've got an n at the top. And what is negative 1 plus 1? 0. Yes. So those cancel. Are you guys with me? Okay. Times minus n plus 3n is?
2n.
Okay, 3 to the power of 2n and then just plus 1. Yeah.
At the first line, it's 2 to the power of 2n, which is 2n.
Where?
Because they cancel out as well the n.
Yeah.
Yeah.
Mm-mm. This must also be a 2n. Is that what you're saying? Mm-mm. Now, last step was to take everything to the top. Okay, so 2 to the power of n is on top. What's going to join that? Okay, when you take it up to the top, it becomes a minus n. Are you with me? Okay. Times 3 to the power of 2n plus 1. Okay. And when we take this up to the top, it becomes a minus 2n. Are you guys with me? Okay, so n minus n is 2 to the power of 0, which is 1, yes, times 3 to the power of 2n minus 2n, cancel, so we've got 3 to the power of 1 left. What is 1 times 3?
3.